Hey everyone, we're asked to find horizontal and vertical asymptotes for this function that kind of guide you through the process. Again, your function might be slightly different than this one. The first thing they want us to do is to find the limits at uh, positive and negative infinity. So what's the limit as x approaches infinity of this function? Well, the form of the limit, obviously the numerator is going to infinity, the denominator is going to infinity as x goes to infinity. So we have this indeterminate form. Now, most of you already know the limit by looking at this, but remember the general strategy was to look at your denominator and find the highest power on x. X squared is the highest power on x. Divide both the numerator and the denominator by that power. So x squared divided by x squared is 1. 16 divided by x squared x squared divided by x squared is 1, and then 4x divided by x squared simplifies to 4 divided by x. Now, as x goes to infinity, we know that this fraction here is going to 0, and this fraction here is going to 0. And so the limit is 1. Most of you knew that right off the bat, and that's fine. In fact, you can look at this limit and say it's equal to the limit of just what? X squared over x squared, because the end behavior really of the top polynomial is the same as x squared, and the end behavior for the bottom polynomial is the same as x squared, the highest degree term. And of course, x squared divided by x squared is 1, and the limit as x goes to infinity of 1 is 1. If you take the limit as x goes to negative infinity, by the way, it's going to be the same thing, right? These fractions will still go to 0, and your limit will be 1. So remember, the horizontal asymptote is y equal 1. So make sure when they ask for the equation of a horizontal asymptote, you give y equal 1. If you just type in 1, it's going to be incorrect. Now, for vertical asymptotes, we are looking for, the candidates are basically 0 or 4, right? Because that's when the denominator is 0. That's when we can possibly have a vertical asymptote, right? If the denominator is not 0, that must mean we're going to get a real output for the function. So I'm going to take a look at 4 first of all. Limit as x approaches 4 of this function. And when I plug in 4, I get 0 over 0. That should indicate more than likely we've got a hole. Let's see if we can simplify. Factor x squared minus 16 as x plus 4 times x minus 4. And then I can divide top and bottom by x minus 4. And I have the limit as x approaches 4 of this simplified function, which I can plug in directly, and I get 8/4 or 2. And so the limit as x approaches 4 of this function is 2, which means we have a hole in the graph, right, at x equal 4, not a vertical asymptote. So at the point 4 comma 2, basically there is a hole in the graph. However, when we look at the limit as x approaches 0, of course, if I plug in, the top will be negative 16 and the bottom will be 0. Well, when you get that form, you kind of know there's going to be a vertical asymptote. And so we want to take a look at the limit from the right and left in that case to see what the behavior is near the vertical asymptote. So as we approach 0 from the positive side, what's the form of this limit? 0 minus 16 is negative 16. In the denominator, obviously we're getting closer and closer to 0 because 0 times, well, 0 times negative 4, 0 times negative 4 is still 0. But again, we're never actually equal to 0, but we're close to 0, but always positive. So notice this will be negative 4, close to negative 4, be a negative number, just emphasize that. And then x is close to 0, but always positive. So x is a positive number. A positive times a negative is a negative. That means we're approaching 0, but we're always negative. So this ratio close to 0 from the positive side, negative divided by negative is always positive. That means we're going to positive infinity. As x approaches 0 from the negative side, then the form of the limit will be negative 16 over 0, but now we're approaching 0 from the positive side because now x is less than 0 is always negative, and of course 0 minus 4 is close to negative 4. A negative times a negative is a positive. Negative divided by positive gives me negative infinity. Again, you can look at these limits numerically, graphically, that will help, but you do need to determine the behavior. Basically now if we were looking at the graph of this function at 0, which is on the y-axis, then as x approaches 0 from the positive side, we're going up to positive infinity. As we approach 0 from the negative side, we're going to negative infinity. So that means, of course, that x equals 0 is a vertical asymptote. Remember, x equals 0, that's a vertical line. In fact, it's the line coinciding with the y-axis. So make sure you do x equals 0 and not just 0. And then also, I think in the problem, they're asking for the limit, for instance, as x approaches a, where you have x equal a as a vertical asymptote from the negative side. So that would be this, because our a is 0 in this case. Okay, and then of course this would be the limit as x approaches a from the positive side. Okay, so I hope that helps. There's some multiple choice options there to select. If not, let me know.